So, good morning once again. And now we have reached to such a level where we can able to differentiate the microprocessor and microcontroller because enough information about those two ICs has been collected. So based on that, we'll have to collect almost 8, 9 differences, and that will carry 5 marks. So if you refer the previous exam papers, you will find question number one. This question is asked for 5 marks, and it's a typical question. The difference between microprocessor and microcontroller. Just a brief overview what we have seen up till, and based on that, we will write down the points of difference between the microprocessor and microcontroller. This section is for microprocessor. This section is for microcontroller. In microprocessor, we said that there was a single chip IC, integrated circuit, which is called as microprocessor. In short, it is called as MUP or MP. And this device will work in association with all the other ICs. Some of them are for memory and some of them are for input output devices. So somewhere here we require to connect a separate memory IC, and we have to connect input devices, peripheral and output devices, interfacing devices. So if suppose like this is a board, this is a wait. So suppose this is a board on which I'm going to mount the IC which is called as microprocessor, and here I'm going to connect memories and input output peripheral devices. So now this is my system like this one. The tracks are for where I'm going to put the IC as a microprocessor, and along with that I'm going to connect the memory and interfacing devices, input output interfacing devices. So this becomes a board. So a system which is uh, designed by microprocessor along with the memory input output. So this system is called as a single board microcomputer. This is used to compute the for computation process, addition, subtraction, logical or, logical and so on. So for computation process, the system is developed on a single board. So this system developed with the help of microprocessor is called as single board microcomputer. Computer which perform the functions in microseconds, that is called as microcomputer. So the first point, please note down, the system design using microprocessor is called as single board micro computer. हा single board आहे. It is used for computation process, so it is called as computer and perform the functions in microseconds called as microcomputer. What about the microcontroller? In a microcontroller, no, we have all these features inbuilt inside a single IC. So here, this is an IC. Partially, it consists of microprocessor that is inbuilt inside. Memory is also available inside it. Input output peripheral devices or interfacing devices are also there. So the system built with the help of microcontroller is called as single chip. This is chip, no? Single chip microcomputer. So you can say that microcontroller based system design जशी ही होती मायक्रोप्रोसेसर बेस्ड सिस्टीम डिझाईन, तसं हे आहे मायक्रो कंट्रोलर बेस्ड सिस्टीम डिझाईन. हे पण काय आहे, दिस इज ऑल्सो मायक्रो कम्प्युटर but that is on a single chip. So called as single chip. हे बघा सिंगल बोर्ड आणि हा आहे सिंगल चिप मायक्रो कम्प्युटर. These things are same, but this, one of them is called as single board, other one is called as single chip. कारण त्या सिंगल चिप वरतीच हे सगळं ऑलरेडी आहे. Shall I go ahead? Savanth left.
Yes, sir.
God bless you. हाँ, साळुंके. Savanth. See, I can call anybody when the class is going on. And if I find no answer from anyone, I'll simply put the absentee. Okay, someone is writing the chat box. That is also fine. Wait, so we'll go ahead now. So please note down the first point over here. Yes, yes, okay, okay. Moving to next point. In this microprocessor based system, if I see the IC, this IC is known as microprocessor IC, and it has three compartments. One of them is called as ALU, arithmetic and logical unit. Second compartment is called as number of registers, and third compartment is called as control unit. And we have discussed enough on this every compartment of the IC or a section of the IC. So based on that, let me write one more difference. The microprocessor consists of ALU, register, and CU. Microprocessor consists of ALU, registers, and control unit. This is what on a single IC. What we can see here. Here we can see the single IC consists of microprocessor. So obviously there must be three sections. First one is ALU, other one is register, third one is control unit, along with the memory, RAM, ROM, input, output, interfacing devices. So here in this microcontroller, we can write microcontroller consists of same ALU, register, CU. हे तर ऑलरेडी आहेतच ना. ALU, register, CU, control unit, along with along with along with RAM, ROM, IO devices. बरोबर. आपण हे बघितलंय की या आयसी मध्ये ना देर आर अदर फीचर्स लाईक इथे असतो टायमर किंवा आहे डायरेक्ट मेमरी ऍक्सेस किंवा आहे सिरियल पोर्ट कम्युनिकेशन. सो ऑल दोज थिंग्स आर देअर. सो आय कॅन राईट इट कन्सिस्ट ऑफ ALU, रजिस्टर, CU. हे तर आहेतच. अलॉंग विथ दॅट रॅम, रॉम, IO डिव्हाइसेस, टायमर, counters, etc. बरोबर. So please note down second difference of this. एकाच आयसी मध्ये हे सगळं असतं. Difference number 3. Now, when I'm going to build a system using microprocessor, obviously I require a ADC because the real-time world where we normally use the analog signal, and this is a system which requires a discrete signal, 1 or 0. So somewhere when the outside signals are to be fed, are to feed into to the microprocessor based system, obviously I must convert the analog signal to a discrete form, and for that I require ADC. So in this kind of system built with the help of microprocessor, definitely we require the ADC to be connected separately. So the difference is ADC required to connect required to connect externally. However, that is not there inside the IC. That is not there in IC. But in this case, now it depends. कधी कधी ना, in some microcontroller, the ADC is inbuilt inside, and in some microcontroller, they may not be there, but they need to connect externally. So we cannot, we will not sure about it every time. So whichever is the microcontroller we are selecting, it is already having the ADC. It's not like. So we say that ADC may be inbuilt inside. ADC आतमध्ये असू शकतो. So that is the sentence. So in microcontroller, ADC may inbuilt inside. त्यामध्ये एडीसी हे असू शकतो. असला तर ठीक आहे, वी हॅव टू यूज इट, अदरवाइज वी हॅव टू कनेक्ट इट सेपरेटली. काही डिफरन्स कळते, समजतंय का डिफरन्स? पुढे
Yes, sir.
तसंच देर इज अ पोर्ट कॉल्ड एज सिरियल कम्युनिकेशन. आता होतं कसं, सपोज आय एम गोइंग टू बिल्ड अ सिस्टम using microprocessor. So I will take a IC, I will connect the microprocessor chip, then I will connect separate memory input output, and then this is my one device built by a microprocessor, and one more device is far away, maybe a computer or maybe other microprocessor based system that is in a different city even. So what I will do, now from this system I will have to transfer some content to that remote system. Obviously I will require one port that is called as a serial communication port, and from that serial communication port I will transfer the data from this system to one more system which is kept far away. But that serial communication port is not available in that IC. I want to connect it separately. That module or that IC which converts a parallel data to serial data or a serial data to parallel data, that is known as USART, Universal Synchronous Asynchronous Receiver and Transmitter. That is for a serial communication. So that is definitely not present here. So I mean to say that must be connected externally to this. So point number 4 is universally synchronous asynchronous receiver transmitter required to connect externally. And हे डेफिनेट आहे. का बरं? That feature is not incorporated in microprocessor. But unlike in this controller, in an advanced controller, that feature is already inbuilt inside. In some of the old kind of this one controllers, they may not be there. So some microcontrollers may be having that, some microcontrollers may not be having that. So sentence will be same. So the serial communication user may be inbuilt inside, not sure about it. Maybe in some cases It may be there. In some cases, it may not be there. So we write USART may inbuilt inside for serial communication. Serial communication for serial communication. Definitely. Here, definitely we require to connect separately, externally. But here it may be there or may not be there. That is not, that depends upon the different variants of controller. Again, depends upon the manufacturer. Okay, so four are over. Now we have to collect some more 4, 5 points. I hope you are taking it down. Please note down all the contents. This will straight away fetch 5 marks in examination. आता बघा, now somebody has asked me to uh, develop a system, and I have two different way to develop a system as per my requirement. I just want to change the illumination of the room or a lab. The same task can be performed by microprocessor, same task can be performed by microcontroller. So if I'm going to build a system using microprocessor, that time I will collect IC, which is called as microprocessor. I will take one more IC as a memory. I will take input, I will take output, interfacing devices, and mount it on a board. Out of that, the IC is separate. So this IC will not work alone. It has to work in coordination with the memories, input, output, and other devices. Otherwise, sole IC, single IC, called as microprocessor, will not do anything. You can write a program, but to execute the program, it requires a support of memory. Without memory, it cannot do anything. So what I mean to say that single IC called as microprocessor is a stand-alone device. Is called as a stand-alone. Of course, to get it done. Okay. So to get the work done, it has to work in coordination with all the other memories and input and output and the other devices. So single device is called as stand-alone device. But that is not the case with the microcontroller. In a microcontroller, again I will take a board on which I will mount the IC. The IC is called as microcontroller, but that IC itself consists of memory. It also consists of input output interfacing devices. It may consist of ADC. It may consist of serial communication device. It may consist of timer counter. So everything is there in a single IC, which I'm going to mount on the controller. So sometimes we feel that using controller is much easier than using microprocessor. And always say, in a microprocessor, if I'm connecting all the devices separately, I will have to go for a rigorous wiring for that. Bus structure is required. Perhaps in a controller, all they are inbuilt inside. Straight away, the hardware requirement has curtailed down to much extent. So we say that microcontroller is not a standalone device. It always work with all the features incorporated inside. Perhaps the microprocessor is the standalone device. To work and to get the work done, it has to work with all the other ICs. So this processor is standalone, controller is not a standalone device. I hope you might have understood this. Okay, right? The fifth point, microprocessor is a standalone device. microcontroller is not a stand-alone device. कारण त्याच्यामध्ये सगळे फीचर्स इनबिल्ड आहेतच ना, म्हटल्यानंतर इट इज नॉट स्टँड अलोन डिव्हाइस. बरं, समजतंय डिफरन्स? जाऊया पुढे जरा. यस, यश नरोटे. यस, थँक यू.
Yes, sir.
Yes, yes, yes. Bye. Okay, okay, fine. Now we are collecting the next point about the processor. Now this point is not yet covered because as we move ahead in the programming section, we will start writing the program. आता बघा, program म्हणजे काय असतं? Program is a set of instruction. So my task is same. This is going to achieve the same objective. This is going to achieve the same task. But one I am building with the help of processor, other I am building with the help of controller. Now what is the difference? See, here, this is my program. And so for this, I will write a program. The program म्हणजे काय? Instruction 1, 2, 3, 4. So I will have to write instructions 1, 2, 3, 4. Yes, this will give me the desired output. इथे काय असेल? Same instruction 1, 2, 3, 4, 5, 6, 7, 8. And this will give me a desired output. So unless and until I write a program for that processor or controller, they will not work. Just hardware. Software is nothing but a program. But the thing is like, in this, we will get a huge set of instruction. And those instructions are mentioned in every catalog of that IC. So for example wise, this may be having instructions. असा एक सेट रेडी असतो, त्यातल्या instruction वापरायच्या. Suppose I have to go for addition. The instruction is ADD. Suppose I have to go for subtraction. Instruction is SUB. If I want to go for logical OR, the instruction is OR. असा एक instructionचा सेट ना तयार असतो. तो किती आहे बरं? Suppose for example, it may consist of hundreds of instructions. Being a programmer, I have to pick up some of them, I have to club it in my program, and that will give me the result. I repeat. So this set is available. Appropriate instructions must be fetched by me. I will club them together. I will rearrange them in a one by one line, and that is my program. Not necessarily I'm going to use all the instructions at a time. I may use some of them. But available instructions, for example, maybe 100 over here. Here in microcontroller, if you want to achieve the same task, so probably all the instructions must be there because we have to go for addition, ADD, we have to go for multiplication, MUL, we have to go for division, DIV, we have to go for logical OR operation, OR. So such a kind of operations, this device must capable to carry out those operations. But the hardware of this device and the logic level is set in a such a way that to accomplish all those tasks which could be accomplished by microprocessor equally, number of instructions available for controller are less. याचा अर्थ असा होतो का त्यामध्ये instruction set कमी आहे, त्यात instructions जास्त आहे, so this is much advanced to controller? No, the contemporary processor controllers can very well and they are capable to carry out the desired task. But then this is going to perform the task with minimum number of instructions. Perhaps it may require a large number of instructions. म्हणजे काय होतं बरं, त्याला म्हणतो आपण ऑपरेशन कोड इन टर्म्स ऑफ, इन शॉर्ट, ऑपकोड. हा काय आहे, तो ही आहे ऑपरेशन कोड, त्याला म्हणतो आपण ऑपकोड. operation code. The operation code, you might have gone through it. Operation code. So in this case, the operation codes are large. In this case, the operation codes are less, but both are equally capable to carry out the task equally as processor, equally as controller. So what is the thing? असं होतं, the opcode given here are not or cannot be modified by a programmer. What is the opcode given is a fix, and that has a single task. Here, the opcode given by the manufacturer can be able to modify by a programmer. So I have a liberty, being a programmer, I have a liberty to little bit modify that opcode, and then I can use the same instruction to carry out some more operations. Addition along with increment of pointer, subtraction along with decrement of pointer. In that way, that facility is available, or I can say that is possible at my end as a programmer to little bit modify the opcode. So this is having a large number of opcodes, this is having less number of opcodes, but these opcodes are fixed. So the data handling capacity of that opcode are less. Perhaps the data modification bit handling capacity of these opcodes are more. So I can reconfigure them, I can rearrange them and use them for a different application. Because both are capable, both devices are sorry capable to carry out the equal operations. The objectives are equally handled by processor and the microcontroller. Now this is our discussion. I will have to put all the discussion in a single sentence. Let us see. The sentence is point number 6. Microprocessor is having large number of operation codes. It is having large number of operation codes. असतात. पण प्रत्येक ऑपरेशन कोडची बिट हँडलिंग कॅपॅसिटी ही कमी आहे. But less bit handling capacity. Instructions म्हणजे तेच ऑपकोड. इथे काय येईल बरं, ते जरा वेगळं येईल सेंटेन्स. यामध्ये देर आर लेस ऑपरेशन कोड्स. इट इज हॅव्हिंग less number of operation codes. Operation codes. पण प्रत्येक ऑपकोड हा खूप स्ट्रॉंग आहे किंवा इट कॅन बी मॉडिफाईड. But more bit handling instructions. ज्यांनी कधी प्रोग्रामिंग केलेलं आहे, but I mean most of you might have done the programming. If you have done it, it may be an Android, sorry, not Arduino, it will be on Arduino, where we get a ready-made functions. In the microprocessor, we will not get a function. For every task, you will have to write instruction line by line. So sometimes we feel that writing a program for microprocessor is quite complicated as compared to controller. Fine, that is always there. Okay, so this is the difference. हा पॉइंट डिफिकल्ट आहे. मगाचे 5 पॉइंट्स सोपे होते. हा पॉइंट डिफिकल्ट का माहिती का? Yet we haven't studied, understand the programming language this one contains. So you may feel difficult. I think you might have taken this. Point number 7. Okay, now this point is very easy. Uh, the hardware required. Bhagan, right from the beginning, I said that I want to achieve the same task. One, I'm going to achieve by microprocessor. Other, I'm going to achieve by microcontroller. So with the help of two different systems, one is built by processor, other is built by controller. I want to achieve the same task. You think I will, Bara? I'm going to connect the microprocessor, memory, input, output, ADC, this one, and then I go for the hardware. I require decoders, I require address buses, I require data buses, I require control buses, I require different drivers. So hardware required in this case is large, obviously. But when I'm going to build the same system using microcontroller, so that time the IC, ALU, resistors, the range
Sir,
is
your screen is blur.
blur, it's blur. I know, I know. Wait,
Your
high
also.
processor so I required for a regular mining, I have to go for a bus structure. Build is a hardware configuration and what is yes. Wait, कहाँ से होते हैं? Okay, am I audible to you? Am I audible to you?
Yes, sir.
And is it
But
visible?
it is still blur little bit.
Blur. And is it visible?
Yes, sir.
Why I can see. Just a minute, huh? Anyhow, anyhow, I think it's fine. hardware required to achieve the same task will be complex and large, but in case microcontroller based machine, the hardware required is itself less. So, you know the point, the range interfacing hardware, large interfacing hardware is required here in whereas in a microcontroller, less interfacing
Again,
hardware
your voice is breaking.
is required. Again, okay, there is a problem in internet. Problem occurred. Okay, students, I think, okay, yes, can you hear me? We should stop here. We will continue tomorrow. You please leave. Okay, I think we should stop here. You please continue. We will- Okay,
Okay, sir.
stop here. You can leave.
Yes, sir.
Okay.